Hi everyone, we are back again, and today we will continue with within neuron transmission. In our previous video we have tried to make us understand what, whenever you hear between neuron transmission, what is it all about? It is just the activity of or movement of information from a particular neuron to another. Please, I will want you to revert to that video and ensure that you understand what we talked about there. Yes, for emphasis, we simply told you what happens, and exactly what happens is what we told you. Yes, please remember to please subscribe. It's really a request. We are still requesting for that. Yeah, please do subscribe to our channel. God bless you. So now, within this time, this is not between two neurons, but in a particular neuron. What happens? I want to simplify it again. Some terminologies you'll be looking out for is what we call intracellular fluid, extracellular fluid, ions, charges. You hear resting state. You hear membrane potential. Right, negatively charged, positive charged ions, yeah, potassium, sodium, all of those things, right? Okay, we'll be looking at state of polarization, state of depolarization, repolarization, action potential, all or none phenomenon, nanoseconds, right? Yeah, all of these things. If you were able to speak English and write English, right? I mean, like trying to explain yourself with all these terminologies in this topic. I think if all these terminologies I use now are captured, yeah, threshold of excitation is also very important. Very important. So if you can capture these terminologies in your writing, I think you have explained within neuron transmission. But let's see how it goes, right? You can't just start writing it anyhow. So trying to understand within neuron transmission, what are we talking about here? We are talking about those things that happen in a particular neuron. So first, you have to make us understand that this is talking about what happens within a particular neuron, and you tell us that the membrane of a neuron, the cytoplasm, right? The membrane of a neuron is found within, within fluids. Yes, within and without. Let me use that word, right? Within and without, like around and inside, there are fluids. Please, I'm writing already. I'm telling you what you should be understanding to do, right? So you tell us that this cell of the membrane of the cell, the inside of the cell of that neural cell, right, is contained intracellular fluids, while the surrounding, the outside, is contained with the extracellular fluids. Keyword: the intracellular fluids are negatively charged, while the extracellular fluids are positively charged. Positively charged, that means there are electrical ions that dissolve inside each of them. The ones inside, mostly like potassium, K plus, is a negatively charged ion. Please don't mind about the K plus. These are scientific whatever. Yeah, I cannot remember those things. How did it? But sure, potassium is a negatively charged. Chlorine is also inside. That is Cl minus. These are ions. They are not in their molecular state. They are now in their ionic state. Even as molecules, right? They are still in. And negatively charged in that regard. So these are intracellular fluids filled with these negatively charged ions. In other words, that liquid inside the intracellular fluid is electrically charged. The extracellular, on the other hand, also is positively. The one of the ions you see there is sodium ion. That's a molecule there. So, but in ionic state, because they are electrically charged, positively charged. So you can imagine the cell of the membrane of the cell, the cytoplasm, or the membrane of the cell. Like imagine you draw a line, a round, just draw a circle, right? Inside, just at the edge of that circle, inside, just start writing minus, 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 minus. At the edge, tip edge, like they wanted to go out, but they could not. They just come at the edge inside. The same thing, the ones outside. The extracellular, you see, plus, 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 round the outer part of the membrane. You know what happens in osmosis? When osmosis, that is a semi-permeable membrane. This cell membrane is a semi-permeable membrane that refuses any large molecule to enter. We call it the ion gate channel, or the BBB, the blood-brain barrier. You remember, okay, you guys will talk about it later in next semester, right? Yeah, but this cell membrane does not allow large molecules to enter. That's why you see that this plus, 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 they are just coming at the outskirts of the body of the cell, round outside, while the inside, the minus, 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 they are in those negatively charged ions. And please flow with me. I'm telling you what you are writing, right? So the way it is now, you will remember that unlike pairs attract. So you notice that this negatively charged, because they're negative inside, they will now be attracting the positive outside, dragging them to come in. So that is how the way they are dragging them to come in, the negatively charged ions also are pushing to go out. So these two forces now equate themselves, and the whole thing is just charged. No one is coming in, no one is going out. This state is what we call the resting state, or you call it the membrane potential. The membrane potential of the cell. The membrane potential of the cell, of the neuron. Yes, please. So this is the resting state, and this is also what we refer to as the polarization state. This is in a state of polarity, right? Now, you will continue telling us that this will continue this way until, you know, why there is no coming in and going out is because the charge is not enough to trigger an action potential, to trigger the cell to fire, right? So the thing remains in this resting state until this process reaches what we call threshold of excitation. The threshold of excitation is the state, the level at which this excitation of this charge or process will reach for an action potential to be generated. I hope I'm making sense, right? So once the threshold of excitation is reached, please remember to tell us that the action potential is triggered and the membrane opens, the positive charged sodium, for example, ions push in, and the negative charged chlorine, potassium push out. Like they rush in, these ones rush out, and that you, when you say action potential has been generated and has triggered, or has been triggered and or has fired, right? This is only at threshold of excitation. This is possible. For action potential to be generated, it is at the threshold of excitation. Now, very important, mind something. This happens in what we call, there are two principles I want to, one principle, but one is, you should know that it happens in a nanosecond. This action potential, this influx and outflux of these ions happen under a nanoseconds. Action potential has taken place. Okay, so that is in that situation. And another thing is that you should note that to tell us that this happened in an all or none phenomenon. All or none phenomenon. In the meaning that the energy is enough to generate an action potential or is not enough. And when the firing starts, it cannot be reversed. When you send an SMS to somebody, there is no getting it back. When you have shot a gun, that gun is gone, right? There is no going back. There is no, oh, I didn't shoot again, right? Okay, so, or, okay, I didn't send the message again. You cannot withdraw that, bring that SMS or mail back because it has been sent. Once it's on, all or none phenomenon, it's either enough to trigger or to fire or to generate an action potential. I hope you are hearing the words I'm using. To trigger an action potential or to fire, right? Or to generate an action potential, or it's not enough. If it reaches threshold of excitation, nothing stops it and nothing reverses it until it occurs. That is that important. Now, that moment, you also know to tell us that that state at which the threshold of excitation is reached, and the state of that cell is what we call a state of depolarization. It has depolarized, reason because meaning that it opened up and altered the state of polarity, that resting state. And what happens? Positive ions flushed in, negative ion flushed out. Nanosecond, everything continued and stopped at the right time they're supposed to. And the whole body calms down and the whole system, we say that moment it returns back from that depolarization state to polarization state. From that time of firing that action potential and everything to the time it restores to polarization. That's what we refer to as repolarization. So the cell remains like in balance, positive equal, round outside, negative equal, round inside, and the charge is just vibrating. Everybody's just equal. Activity is just there. The amount of the one going inside and the one going outside at this point in those fine tiny molecules are equal. And this is the state of polarization. When action potential is triggered in that threshold of excitation, the state of the cell depolarizes, allowing the positive to go in and negative to come out, those charges, right? And it happens in a nanoseconds and continue firing till the state of polarization is reached again. That is when it repolarizes back. And this is the explanation of what happens within neuron transmission. This is all you will be expected and be needing to discuss when writing about this. So in summary, within neuron transmission, I emphasize on the extracellular fluids and intracellular fluids. The one inside is negatively charged with, example, chlorine and potassium. The extracellular, we have the sodium, which is positively charged this time. And we say that the membrane of the cell, the blood-brain barrier, for example, the ion gate channel, do not allow larger molecules to penetrate, but only fine tiny molecules. And for this reason, it does not allow them to go in anyhow they want. So by their negative and positive attractions, right, unlike attractions, they come at the membrane and charge and equally just stick or stuck on those places. And at this balanced situation, we call the resting state or the membrane potential of that neuron. And until the threshold of excitation is triggered or is reached, it will not fire. But once it's reached, depolarization occurs and in and out happens, like I explained. Action potential is generated, and there is a trigger, and there is a firing, and this is within neuron transmission. Like I said, all unknown phenomenon, please remember to explain that on to nanoseconds and all of those things, polarization, repolarization. If you can remember to explain them, you are good to go. This is what you need to know. Please do like, share, subscribe to our channel, and so you can really check out other documents and materials we have for your lectures. Thank you, and see you in other videos.